All right, let's get started. So we're continuing testing. We did testing tips on Monday. We're going to do more, I guess, just testing tips. I can still call it again today. And it's going to be focused on classes and data structures today. Last time was organizing testing for methods. We tested a few methods, just some boring math methods. Now I want to create a class. The code for the class is already here. We're staring at it. And how are we going to test this thing? And specifically, the big thing I want to focus on is when a method returns an array list of classes, which is getting closer to what you have to do in the homework. In task 3, you have to compare two linked lists of classes. So let's talk about how to do this stuff. And as always, with these more open-ended, these coding lectures, they are more open-ended, so if there's something specific you want to see, I'm fine going at least a little bit off rails on this one. Today, Friday as well, we can go off track a little bit, especially if there's something that a lot of y'all are struggling with on the homework. I would rather talk about that. What I have is what I think will help you on the tasks, but if I'm wrong, let me know and we can talk about something else. There's nothing that we absolutely have to cover this week. It's all helping you do better testing, get through AutoLab with fewer submissions, with less time, saving you time on writing these tests. So anything that can help you specifically, I want to know about it and do it. All right. So we have a bank account class. Let's go through what the class is first. We have two instance variables, a string and double. Whose bank account is this, and how much money do they have? Those are the two things that we want to remember in this class. Those are the two instance variables for this class. The constructor is going to take those two instance variables and initialize them. So a pretty standard constructor initializes the two instance variables. A getter for the account holder. A getter, which I called check account instead of just get money, because get money sounded like we're withdrawing money, so I named it something else. Deposit and withdraw, they're both going to return void. And then transfer, since we have classes now, our methods can take references to other objects of that type. So transfer, which takes a reference to another bank account and the amount of money to transfer, we're going to withdraw that money from this bank account and deposit it in the other bank account. So we got some reference magic going on here, making sure that we're tracking our references the right way and taking advantage of the keyword this and also the fact that this is passed by reference and we're going over to the heap, calling a method which will modify the instance variable of that object on the heap. It's kind of a mouthful, but at this point, I would hope that you can all follow that one. It's been 2.5 weeks since we talked about classes for the first time. So references, objects, classes, all those should be getting pretty familiar at this point. And finally, one method that actually does a check, a little more than just moving money around, checking if the account is overdrawn, which if money is negative, then it's overdrawn, and we're going to return true. If it's not, we're going to return false. So if it's exactly 0, it's not overdrawn. This is doubles, so we'll rarely ever have exactly 0 with truncation errors and the like. But if it is exactly 0, we're going to consider it not overdrawn. And then we can test this. I didn't want to do this during lecture because it just takes a lot of time, and you've already done this on task 2, is testing an actual class, calling the getters, calling the setters. I'll just remind you all of the little things to keep in mind when we're doing this. When we're checking a class, when we test a class, we're first going to need to create an object of that type. So I'm going to create a bank account object and test the class through that object. And whenever I want to check the value of one of its instance variables, since those variables are private, I can't check their values directly. I'm just not allowed to do that. Instead, I'm going to call the getter methods and get the value and then see if the getter returned the right value that I expect it to have. So I'll create a new bank account. The account holder is Matt with $100. And I'm going to assert right away. I created an object. I'm going to assert that the getters return the right things based on the constructor parameters. I'm going to assert that the account holder getter is going to return the value Matt as it should, and the account should have $100 in it, so check account should return $100 within a tenth of a penny. And here's where we can think about our epsilons, our tolerance for our double comparison, which I call epsilon when we do the compare doubles thing. We have to think about what that actually means. In this case, if I'm off by a tenth of a penny, up to a tenth of a penny, I'm okay with that. In this instance, if you're not okay with that and you want more precision, increase your epsilon and allow more precision. When we're talking about money, if we had, say, 0.01 and we can be off by a full penny, it's probably a little too loose of a tolerance for our application. If every calculation is off by a full penny, you could be leaking a lot of money. Even a tenth of a penny might be too much. But for our purposes, I'm just checking a getter. We're probably going to be okay. If you're computing compound interest and every calculation is off by a penny or even a tenth of a penny, you probably want to tighten those bounds by quite a bit. All right, we're going to deposit $5.50 and make sure check account returns what we expect it to return within a tenth of a penny. Deposit another $1, make sure we get another $1 in the account. Withdraw $10, make sure check account updated properly. Create a second account with, I have a little shy of $20. Make sure that I am the account holder because that's what I gave the constructor. So making sure the constructor and the getter works. We can't really test each of those individually. We have to test them together because we have no way of checking, no convenient way, I should say, of checking the values of the instance variables in another way. And then I forgot I did this. I looked through these before lecture too, and I still missed this one. So this test case, this one still passes. By the way, we can run this. This passes. On Friday, they won't pass, and we'll do actual debugging. But these tests pass. And here's an instance where I'm checking if check account returns 1.5, but with an epsilon or a tolerance of almost $20. So this is where, again, we have to be careful what our tolerance is. If our tolerances are too loose, we could have very, very wrong answers. I mean, this code is correct anyway, but we can have very, very wrong answers and still call that code correct. So this, what this returns will be 1995, which is within 1995 of 1.5. So my test case is completely broken because even if check account returned $5, this test case would still pass. This test case would still be like, yeah, you're good. So we have to be careful of what we use for epsilon here. I shouldn't even have this checked into the repo like that, actually. I should change it like during lecture. And then this test case will fail because the test case itself is broken. Then we change this to 1995. Check that in. Oh, I can't. That's why I'm not. Damn it. All right, and then I'm going to call the transfer method. This is a bigger one to test, so I want to transfer from Matt's account to my account $50.50, and after the transfer, did Matt's account go down by 50.55, and did my account go up by 50.55? Checking to make sure that both accounts have the amounts that they expect. This transfer is going to happen by reference. The transfer method has a reference to Matt's account through the keyword this because it's the calling object, and a reference to my account through the parameter, through that bank account parameter. So it has both references. It can go to the heap and modify both of our instance variables, and we want to make sure that the instance variables did update through the getter method. The getter should return the current value of the instance variable and make sure that those objects did update properly is what the way we test that transfer method. So a little bit more moving pieces, but not too bad, not too complex, in my opinion, I guess. And then we'll check if our accounts are overdrawn. They shouldn't be, so is overdrawn should return false. I'm using the assert false here. There's all kinds of asserts. By the way, if you want to dig into the library and use all kinds of stuff, you have assert true was the first one we looked at. Assert equals was the next one. Assert false I'm using here. And then for linked lists specifically, there's assert null and assert not null. might be handy. You can always do assert true, node equal null, node not equal null. That works just fine. But if you want to be fancier with it, if you want to explore the library a little more, you can do assert null and assert not null. Makes the code a little cleaner, and gives the library your intentions better. And the real reason, it just makes your code easier to read. And then I'm going to call withdraw. I'm going to withdraw $50 from Matt's account. Assert that the account has the appropriate value, right amount of money, negative overdrawn by $4.05. So I'm checking some of the edge cases here. By the way, I wouldn't call this a complete test suite. I only called transfer one time. I didn't call transfer with like negative values. There's a lot more that we can do here. But this just to show you how the mechanics would work. For a real test suite, I would have to build this out quite a bit more. Maybe I should. I wrote this during a lecture one time, and when it's the end of lecture, that's the end of testing. Maybe I should go back and just update it. And then I want to make sure is overdrawn returns true when our account is overdrawn by 405. Okay, any questions on any of that? I was going to do this live during this lecture too, but I'm like, I think they're beyond this right now. So if I'm wrong, please let me know. I'll spend a lot of time on this if that's where we're at. The difference between stack and queue, we can talk after lecture or office hours. This is just not related to what we're doing today, unfortunately. If you asked on Friday, I would have been happy to. I can give a brief example, I guess. Stack, you're going to work with only the front of the linked list, and queue, you're going to add in the back. You're going to append to the back and remove from the front. Very brief explanation of it. And we did both with linked lists. Yeah, we built a stack and queue. We built both of them off of a linked list. I'd be happy to get any questions. So even if it's not related to what it is today, I'll just give you a briefer answer if it's off topic. I'm watching my phone too, if you have questions there as well. I'll go back to bank account if I see a question about it pop up. Otherwise, and the big thing I'm focusing on here is how to test the class. Again, we're pretty well beyond task 2 at this point. If you're still working on task 2 and you have questions, let me know. But I assume just the placement of this lecture in the grand scheme of the course. I think none of this is really new because you've already done it when testing the song class. You already tested the reviewers rate song method, which is about as complex as the transfer method. So you've already done stuff at this complexity. Yeah. For setters specifically, I'd recommend the second one. So when you're testing like the constructor, the getters, and setters, you'll create an object, call the getter, call the setter, call the getter, make sure the getter is always returning what you expect. And then once we start doing more things, then you can start using like the compare methods that we're writing. Then I'll recommend writing the compare methods. So for example, when it's the reviewer class and you're testing the rate song method that returns a rating, that's where I would start using the compare ratings method. I would get a rating from that method. I would create a rating and then call compare ratings, assert true compare ratings of these two ratings. But for getters and setters, it's a little bit overkill. In the compare song method, well, is that safe to say? Yeah, it will come up later. The compare song method, you might not have even used in your testing for task 2, but it will come up in later tests. You'll find it handy to have that. Yeah. In bank account, I didn't, but that is the next thing we're about to do in the bank class. We're going to use it in rate list there. In bank account, it's double inner string. Yeah, I think I clicked on bank at one point there. Yep. Yep, that's the big thing I want to go over today, because that'll be a little bit more new, and it'll be, I wanted to release Task 4 yesterday. I didn't quite get to it, so probably tomorrow Task 4 will pop up. But part of Task 4, as a heads up, is we're going to have a movie class that has an array list of strings to represent the cast of that movie, and we want to test if two movies have identical cast lists when the capitalization of the names can be whatever we want it to be. If it's all caps or all lowercase or some mix, we should always treat it as the same. And, I don't even remember off the top of my head where. I don't even remember off the top of my head where it comes up. But there will be testing. You will have to test where the order, it comes up a couple times, where the order doesn't matter of an array list. The values in an array list need to all be correct, but in any order ever. And I'm blanking on what task that comes up on, but we're going to talk about it right now. Unless there are questions, no questions in chat. They're still talking about 312 content in chat. All right, so let's introduce the bank class. The bank class is going to have an array list of accounts and an add account method. So this is similar to your song class. It's made to be a little bit similar, but we're going to use an array list instead of a linked list, so we can focus on a little bit different things, specifically the order for this, and doing comparisons that don't use dot equals. Those are the two things I want to focus on. That's what this example is designed to do. And this is the method that we're going to test, because this is just a not even a setter, but it'll just modify an instance variable. And I don't even have a getter for the bank accounts, so I can't even return this array list at all. So I don't really have a way of testing the add account method at all, except through this get large accounts method. So this method is going to take some threshold as a double and return all the accounts that have at least that much money in it. Nope, I did do strictly greater than. Strictly more than that amount of money. It's a double, so the equal doesn't really matter anyway. Everything's going to, with doubles, comparisons always need that tolerance. So that's why I forgot it off the top of my head. But strictly greater than the threshold. That's what we want to do. And for what it's worth, the code, I'm going to iterate over all the accounts. And if the account has more money than that threshold, add it to an array list that we're going to return. And I'm using the add method with two parameters here. The first parameter is going to be the index where I want to add the value. And the second parameter, the second argument is what I want to add. So if I call add with just one argument, it's always going to add to the end of that array list. So by adding 0, comma, I'm adding to the beginning of the array list. It isn't really something there's just a reason to do that for this lecture. I want the order to be kind of out of whack. Like Python, there's a .lower function. I'll do you one better. In Java, there's a .compare ignoring case. I don't know if that's the exact spelling of it, but compare ignore case with strings. So if you have two strings and you want to see if they're equal while ignoring case, just call instead of dot equals ignore case. So you don't even have to change the values at all. Just call equals compare ignore case. And that'll be a hint in the handout when that's relevant. I'll put it right in the handout. Hey, this is a method that exists. Don't forget, just use this. Because I don't want, I've seen students in the past, iterate over both strings and compare the ASCII values by adding 26 or subtracting 26 to see if it's the capital or lowercase, really overcomplicating it. I don't want that part to be overcomplicated. Just call equals compare case, or equals ignore case. Okay, so this is what we want to test, this get large accounts method, and make sure this returns the correct array list with two things to keep in mind. This array list stores references to objects on the heap, and the order is never specified. Nowhere in this method description does it say returns all the accounts in some specific order. In the homework document, sometimes they'll say return them in the order in which they were added. For the song ratings, the linked list, the order does matter there. Return the ratings in the order in which they were added. And that's specifically to make testing easier. With linked lists, doing this same thing where order doesn't matter is a complete pain. It's really, really frustrating to do, and I don't know, it's just a pain. With array lists, it's not too bad. So when the order doesn't matter for the assignments, it's going to be with array lists. I won't give you a linked list where order doesn't matter just because it's so painful to test. I don't even want to write those tests, much less making all of you do it. Too painful. So the array list, I'll always specify the order in those things. Linked list, I'll always specify the order. Array list, I sometimes won't. But again, I'm blanking on exactly where I did that. All right, so bank, we're testing a class. The very first thing we'll need is an object of that type. Bank did not have a constructor in the class, which means we get the default constructor, which takes no parameters and doesn't do anything. So if we don't specify a constructor, we get the default constructor. JUnit is a powerful library. JUnit's been around forever, too. They've had a long time to update the library and add all kinds of cool features to it. There's a lot that it does that I don't use in class. There's so much cool stuff in there. I'll sprinkle in tips every once in a while when I can get them in, like the assert not null, but there's so much in there, so much that library can do. Okay, so I want to create a bank, and I want to call the add account method. So let's add some accounts to this. Let's do it this way. Jesse, I'm going to give myself a little bit extra money. I'll go a full $20 this time. Paul's going to be in debt. And we'll give Carl some money. He can have $105.67. Okay, so we have our bank accounts set up, and I want to call my method array list of bank account, big accounts equals bank dot get large accounts, and we'll say $80. So we'll get Matt and Carl. And also when I'm doing live coding, I think I said this before, but I guess worth repeating. In 116, I'll throw in tips and tricks all the time. Whenever I'm doing live coding, I'll explain just random things that come to mind. I could do 80, the one thing right now. I could do 80 right here. This is what we call a magic number in programming. I guess technically I have 4 of them right here. This is a magic number. It's a number that doesn't have any intrinsic meaning. It has no meaning in the code itself. I assign it meaning just by the usage of that number, but nobody reading this code necessarily knows what that number is. They can infer, they can look at it, okay, it's your input for this get large account, it's probably your threshold, but if I name it, give it a variable, store it in a variable, now I get a chance to give it a name. Now it's clear that this is the threshold. It's some threshold of bank accounts. I could give it a more descriptive name if I want. At some point, you got to stop. But I could say, I don't know, big. Actually, let me show off another thing while I'm here. I want to change the name of it, but I don't want to change it here and here. If you right-click on a variable and go to refactor and rename, it'll rename that variable everywhere. So let me say big account threshold. Now it's very clear what's going on. These are still magic numbers in here. These are magic strings. I think these are self-explanatory enough that I'll get away with that one. But here's my naming of this. What we want is self-commenting code. If I create a variable for this value and use the variable, that variable name effectively acts as a comment for what this value is supposed to mean in the context of my code. So we like doing this to avoid those magic numbers. Just in general, obviously not all the time because I'm doing it here. I could do like Matt's cash amount, and then I'm not going to do all that. All right, so now we have big accounts, and this is where I don't want to iterate over big accounts and just check to see if it is what I expect it to be. That gets tedious, especially because my goal is always make it easy to add more test cases. So I don't want to have some big mess of code here. I want to get down to what's my input. My input is this. And what's my expected output? Those are the two things that I need to give a test case, which can't be factored out in any way. Anything else can be factored out, and I want to put it somewhere else. And that sense will probably be a little more clear once I start coding it. So what I want is an array list of bank accounts, which is my expected. Now we did this with the math examples on Monday, but they were just like ints and stuff, so it wasn't that big of a deal. But now that we have objects and specifically a data structure of objects, it gets better to create your expected and then check your expected against your actual. So actually, let me call this actual. Actual big accounts. Expected big accounts. Arrays.asList. New bank account Matt. Bank account Carl. Now, a few things that I'm doing here. One, I'm going to use my auto formatter again. A few things I'm doing here. When I'm creating my expected and I'm working with objects, if I'm going to, and we're eventually going to compare these two array lists, of course. This is where if it was songs, ratings, reviewers, or lists of ratings when you get to homework 3, test 3, you would call your helper method and have your method compare the things and then assert true that method returned true. When we do this, when we're dealing with objects, I'm going to create new objects to compare my expected with. There's a danger that some developers are tempted to do, and that's bank account 1 equals this. You might be tempted to do this. Don't do this. Hopefully my tone made that one clear. But don't do this. But you might be tempted to do this. I'm going to populate my bank with these 4 accounts, which you would update the values to. With these 4 accounts, I have to update these values at least so the expected is right. Put these accounts in my bank, get the big accounts, and my expected big accounts is account 1 and account 4. So I put that in my expected. The problem with this is everything's being passed by reference, and my expected is references to the same as my actual bank accounts. So once I put these bank accounts into my bank, the bank is the code that I'm testing here. Assuming that I already tested bank account, those tests pass, and I'm happy with the bank account functionality, this test is designed to test the bank class. So as soon as I give something to the bank class, I cannot trust it. I can't make any assumptions about it. I don't know anything about the bank class because that's what I'm testing. I can't be testing something and just assume that it does what it's supposed to do. I can't assume anything with it. So when I call add account here and call get large accounts, one of these two methods might go over to the heap and mess with my objects, mess with the states of these bank accounts on the heap, mess with their instance variables. And since this is by reference, now account 1 and account 4 are also wrong. Now my expected isn't actually what I'm supposed to be expecting because the code that I'm testing messed with my actual, my expected outputs. So I don't want to give these references to the code I'm testing, and then also use references to the same objects as my ground truth, as my expected values, because they're not my expected values anymore. They can't be trusted because I handed them off to untested code. So don't do this. The other issue with this is you're going to be tempted sometimes to do in your checks. I can't set up an example real quick. You might be tempted in your checks to test these by reference. So if we ever do something like assert equals account 1 actual big accounts dot get of 0. If we did something silly like this, where we're going to assert equals that those values are the same. Well, those values are references, so as long as what we get is a reference to that bank account that we gave it, then we're going to be okay, and we're not actually checking the values. We're not checking the account holder or the amount of cash in that bank account. We're checking, do these two variables refer to the same object, which they might not refer to the same object, but they might be correct. They might still be returning the right values, which isn't going to give you what you want. So a lot wrong with that stuff. Just don't do that. Don't do that. We're going to back this thing all the way up. And do things the right way. So when we're creating our expected, create brand new objects. Brand new objects. I know my expected is exactly what I'm supposed to be expecting now. So if there is a bug where my bank code went over to the heap and started messing things up, I'm going to detect that because I'm checking, are these the exact values? These 4 values, these are the ones that I want to check. Are these 4 values actually what I want them to be? And we can do that. Again, this is going to be a bad way of doing things. We're going to do assert equals expected actual. So we're going to assert, do I have what I expect? And we don't. In our expected actual, we're going to see these references and no useful information. Actually, it is kind of useful information. No, it's not useful information because I created new objects like I'm supposed to, so all 4 references are different. It doesn't tell us anything. And the issue we're running into, for comparison, actually, array list of integer numbers 1 equals. Set this up quick. Yeah, we didn't go over circular linked lists, but it's. I would expect you to be able to get that if it were an interview question. The interviewer will never say, explain what a circular linked list is. That's completely unfair. But they'll describe, if I mess with the references in this way, we want to test, do you understand linked lists enough to understand the implications of that? I can't say much more than that, just in case you do get that question. I don't want to ruin it. But any inferences that you can make based on, if you have the understanding of linked lists that we expect, we should be able to go a step further than that, and you should be able to figure out like the next thing, not by name, but you should be able to, given a description of the next linked list topic, you should be able to think your way through and understand what exactly the implications of that are. That would definitely be a fair expectation. Because if you can't answer that, I'd argue that you didn't really understand how references and linked lists actually work. And what we get in interviews is some students like to just memorize the slides. And if you're just memorizing things without understanding what's going on, you should fail the interview, to be honest. The interview is all about your understanding of the concept, not your memorization of it. Anybody can memorize facts. Like that's what you do in high school. We don't do that in computer science. You need to understand what's actually happening with these things. Can you explain how a linked list works in memory? And if we change it around in memory, what are the implications of that? So it's definitely a fair question. I might even came up with that one. I like asking that, so I probably did. If we have two, bless you. If we have 2 array lists of integers, we comment this crappy code out. equals numbers 1, numbers 2. So if I have two linked lists of integers and I run this test and do assert equals, this will pass. This will actually pass. So what assert equals does when you give it two array lists is it will go through the values at each index and make sure that they are the same by calling the equals method on them. So does 5 equal 5? Yes. Does 6 equal 6? Yes. Does 7 equal 7? Yes. We're all good. That's what assert equals will do. Let's see if we can get in here. Because assert equals will just call dot equals. Go down this rabbit hole just a little bit. And the array list equals method is going to iterate over the indices. If it's given another array list, it'll iterate over the indices of both array lists and check, does the index of this one match the index of that one using the equals method, which it's using objects.equal here in case, which is our case that we have. No, that's not really true. If it gets primitives, but I guess it's not primitives because it's the integer class. But it will iterate over the indices and check. For each index, do these two array lists have the same elements based on its equals method? And before that, most important thing, check the size. When you're comparing two data structures, check their size. If they're not the same size, they're not the same data structure. They can't be. They don't even have the right number of elements. Done. It's over right there. And then go index by index. So this actually works with integers, but it doesn't work with our bank accounts because when I do my bank account dot equals, there is no method. There's no bank account dot equals method. So when that code calls bank account dot equals, I can't call that through the class. That was a bad mistake on my part. So let's create a bank account object because this is a non-static method. Create a bank account object, which, by the way, this resolves to a reference. You can call methods directly from the constructor. This is legal code. And it'll take me to this equals method, which just calls equal on the other object that you're given. The reason for this is I never wrote an equals method, so bank account has the default equals method, which in our case here is going to compare by the way, I can give this a parameter and get rid of that error. This is legal code. This will work. It'll return false for what it's worth because those two things aren't equal. But what it's going to do is compare by reference. It's going to compare, does this object or does this reference refer to the same object as this reference, and return true or false based on that. So when I do assert equals and give it two array lists of objects that I created and did not write an equals method for, then it's going to say, does the first element in this list equal the first element in this list? Are they both references to the same object? And since they're different objects, that's going to return false, which is what we want in most cases. We want to make sure that the objects have the same values, not that they're literally referring to the same object on the heap, because somewhere in the bank code, it might have created new objects and swapped things around some way. That's totally fair for it to do as long as it retains the right information for the bank account. Who cares how it's represented in memory? So we don't want to check the references. We want to check, does Matt still have $100? Does Carl still have 105.67? And in our purpose right now, did get large accounts return these two accounts exactly? So that's what we want to do. Not assert equals. All that to say, assert equals will not always do what you want it to do, even though you're comparing two things for equality. So we need to do something else. And here's where I'm going to write compare array lists of bank accounts. Oh, I'll keep going. Where order doesn't. Let's just cap it. Expected, actual, assert that this is going to return true. Actually, the assert true isn't really necessary. Just the way some of you set it up, it is. So I want to do that just to keep everybody safe. on the assignments. And then make sure I do this public for the same reason. Boolean. Array list of bank account expected, actual. So I'm taking two array lists of bank accounts, and I want to see if these are equal. And my first attempt, which will be a wrong attempt, I'll give the heads up right here, is do the same thing that the array list class itself is doing. Go through the indices one by one. So first, I'm going to assert equals expected.size, actual size, because if they're not the same size, we're done. There's nothing to talk about. We're just done. This should always be your first check. I shouldn't say always, but for example, with linked lists, it's actually, I find it easier to have the size be implied. If you reach null in one of them before the other, then you know they weren't the same size, and you can do it that way instead of writing a size method. For array lists, I'm always going to check the size. And for complete thoroughness, I won't ask you to do this with array lists on the homework at all, but assert not null, the actual. I don't have to assert not null my expected because I have full control over expected, but I don't have any control over actual. That's what I'm testing. So we should assert that that's not null. Or else on actual dot, as soon as we hit this dot, if actual is null, we get a null pointer exception. You can't follow a reference of null, and that's what dot does, is follow the reference. If there was a bug in the library, all your tests would still pass? Does this mean you can't always rely too heavily? Was there actually a bug in the library? I find that hard to believe. Generally, you don't want to write tests for libraries. Oh, if you were using, I see. I thought you meant in 116. Like, am I using a library like JUnit? I don't use many libraries for 116 in a separate project. I see. Yeah, you generally don't want to write tests for libraries because you assume they're right. But yeah, if you're using a crappy library, I don't know. Maybe you do have to do some testing with that library. If it's open source, you could write testing and contribute it to the project. Okay, and I want another helper method, public, Boolean, compare bank accounts. Worth mentioning now, I guess, is a fine time. When I code, as you notice, I rarely code in order of the code. I don't write line 1, line 2, line 3. I'll code in the order which I think of things. So once I think of something, I'm going to code that part of it. I'll sometimes start at the bottom of a method and write it, hop all over the place and write my code that way. So when I'm doing live coding, you're going to see that. Bank account 1, bank account 2. I didn't get creative at all on those names. And then assert equals bank account 1 dot get account holder, bank account 2 dot get account holder, extra brace in there I got to get rid of, but that was easier. Money, what the hell did I call that thing? Check account. Because I'm going to need to do this and then return true. I'm writing this specifically to fit the way we do it on the homework. I don't know if I'd actually write these like this. I would usually have this return void, but I wanted to leave the option open if you want to use asserts in your helper methods, your utility methods, or if you want to return a big old Boolean result. I leave that open for either way. So I'm using both ways here. Any way you want to do it is fine. I gave you the option on that one. I prefer, personally, doing void and then removing this. But I figure some of you probably won't want to do exactly the way I like to do it, so I had to return Boolean. And if you like it the way I do it, just return Boolean and put return true at the bottom. But if you want to work with Booleans directly, you have that option too. Anyway, let's start iterating through this. So for I expected dot size. Now, I know they're the same size, so I can use either size, but out of paranoia, I always go to expected for this. Let's get my return true so I can get rid of that error. And then assert true, which the assert true is unnecessary. I don't know. I just like having it there. Compare, where am I? Compare bank accounts. Expected dot get I. Actual dot get I. Okay, so we're checking the size, iterating through, and making sure all of the bank accounts are the same. I'm going to run my tests, and I'm going to panic when it fails. This fails, comparison failure, Matt, Carl, well, that sucks. So what I did here, this might be where we start on Friday. Actually, the next thing I kind of want to do is debugger, so this will be a perfect segue into Friday. We'll start with the debugger and explain what's actually wrong with this. But I'll give you the answer right now, is I'm getting the right values, but they're in the wrong order. I'm expecting the order to be identical in the return value and saying index 0 will be this, index 1 will be this. The solution is returning the right information, but in a different order. So in my testing, I have to account for this. I have to say, well, if you give me these two values in any order, I have to be okay with that. And yeah, the music's going to start, so we'll pick up there on Friday.